Welcome to our presentation of phenomenon-based learning. My name is Vanessa Spiegel. I am a master trainer for CCEFinland, and today we will be talking about phenomenon-based learning and what it means, how to implement it. So let's get started. In the presentation today, we will do a short introduction about phenomenon-based learning, talk about its origin and its core principles that are the heart of its approach. We will break down the phenomenon-based learning structure and the practical application. We will look at some examples. We will look at how it's connected to transversal competencies in Finnish education. I have a step-by-step approach to integrating phenomenon-based learning into your curriculum or your lessons. And then I will present some activities, one example lesson plan, 2 assessments, and reflection tools for deeper understanding. So let's dive right in. What is phenomenon-based learning? Basically, it is an approach to learning that is not single-minded. So phenomenon-based learning takes real-world 21st century problems or challenges in society and asks students to observe, to question, and to investigate and possibly solve these kinds of challenges. So it's not really one particular subject. It covers many subjects, maybe not all subjects, depending on the project, but students will look at it from a variety of angles in order to better understand the issue or challenge. It's not worksheet based, so it's inquiry based. It starts with a question and ends with reflection questions. And it is not teacher led, it is student driven. So where their interests lie as a student is where the phenomenon-based learning will take them. This approach transforms classrooms into vibrant spaces where curiosity drives learning and students become active architects of their own knowledge. So why does phenomenon-based learning matter? Just briefly, I want to cover this. In today's changing world, right? Every day we have new discoveries, we have new things happening with technology and just the world in general. And so we really don't know how the future is going to look. And so with phenomenon-based learning, students take more the knowledge that they have and they look for or investigate ways to solve these problems instead of teachers giving them solutions to already established problems. The students are looking at new problems and finding new solutions. So what it does is it creates critical thinking skills. It allows for agency and ownership of the learning journey. It creates ways to collaborate and communicate with their peers. And it's a real world relevant topic. So students are applying their learning to actually what's happening around them. It is multidisciplinary in that we include many different subjects in the way that we approach the issue or the challenge. And it develops confidence in the students because they are given autonomy or agency to be creative in how they work through the challenge. Finnish roots of phenomenon-based learning first emerged as an educational reform, particularly in 2016 in the National Core Curriculum. This framework revolutionized teaching by emphasizing cross-curricular and expertise and student-centered approaches that have made Finnish education globally renowned. So its core principles are inquiry, reflection, student voice or autonomy agency, and real-world problem solving. And it follows the Finnish philosophy that there's less content. We take one particular issue, but it's more in depth. So we focus on this issue and we look at it from so many different angles and possibilities for solutions. Rather than racing through the topic, students are given opportunity and time to dive deep into the issue and find the core principles and challenges that are causing this phenomenon. It's less pressure because it creates, which develops more curiosity. By reducing the testing anxiety and performance pressures, students develop genuine love for learning and exploration. So what is the cycle of curiosity and agency? This is at the heart of phenomenon-based learning. So we always are going to start with a question, and later on in the presentation, I'll talk with you a little bit about what those questions, what a good question is. But it starts with a question that is generated authentically from looking at an image or just having a small discussion about an issue. Students will then investigate and explore. They'll do experiments, they'll gather evidence, they'll do research, and then they will create. So students will synthesize their learning by creating artifacts or models and do presentations. Then the student will reflect, and it's not only at this point that students will reflect, they will reflect throughout this process, this learning process, but for sure at the end we will also do a reflection process, self-reflection, and learners will examine their thinking, the process, and the growth through their journey, and then they will share their discoveries with their peers and the community. This cycle, the cyclical process transforms learning from a linear transmission of facts into a dynamic, iterative journey where each phase deepens understanding and fuels the next round of curiosity. So the phenomenon-based structure from a Finnish model looks something like this. So it provides a comprehensive framework for designing and delivering a phenomenon-based unit over a month's time. So this isn't a one-day activity. It isn't even a one-week activity. We're really giving the students an opportunity to deeply dive into this challenge. So first, we have our core phenomenon. So we can choose a rich multidisciplinary phenomenon that connects to students' lives and meets our curriculum goals. And I will give you some examples of some good phenomenons that we can choose from in a minute. Second is the inquiry question. This is an open-ended question that sparks curiosity and guides investigation across disciplines. Third, we have our sessions twice a week or 3 times a week, whatever the schedule allows, for deeper exploration in the classroom. This is not homework that is sent home. This is in class digging deeply into this challenge because you include small group activities, you include individual activities in large group discussions, that kind of thing. Then we have student-led investigation. So here we design opportunities for the learners to pursue questions through observation, experimentation, and research. This can be done through stations. It can be done through discussions. It can be done through technology and research. And then we have the collaborative tasks where the students will work in groups to build not only their communication skills within their peers, but also in how they want to present collectively the knowledge. Then we will move on to visible thinking routines. So these are incorporating reflection protocols that make thinking transparent and shareable. This is where teachers can really take note of what is being learned and put that in their progress reports or put that in their portfolios. And then, of course, the last step is reflection and assessment. So we have formative assessment and metacognitive practices to document and celebrate growth. So here are some real examples that we can use in the classroom with an example phenomenon question. Number 1, rain and water systems. Where does water come from and where does it go? Community helpers. How do people work together to support our community? Human body systems, how do our bodies work to keep us healthy? Local ecosystems, what lives in our environment and how do organisms connect? Weather and climate, what causes weather patterns and how do they affect us? Markets and money, how do people exchange goods and make economic decisions? Migration, why do people and animals move from place to place? Light and shadows, how does light behave and create shadows? So you can see here that these questions can go in so many different directions, right? It's definitely not going to lead every student to the same conclusion because we can look at it from so many different ways and we can observe so many different aspects of this phenomenon. So it really promotes agency and autonomy in the classroom. Students can work with other students who have a similar interest in that area, or they can do it individually if there are not other students interested, right? So it's got a lot of diversity. It's got a lot of differentiation here so that you can allow the students with a stronger educational background to do more. And the ones that are struggling, maybe if they're in the English as a second language program or they have learning disabilities, they can approach this phenomenon, whichever one you choose, at their level or at their pace. So what are the 7 transversal competencies that phenomenon-based learning supports? Here we have the 7 that are foundational for Finnish education. Thinking and learning to learn. So students develop metacognitive awareness, inquiry skills, and the ability to direct their own learning through this phenomenon-based cycle. Cultural competency and expression. Phenomenons are explored through multiple perspectives. Not only subjects, different subjects, but also within one subject, there can be different components as well. Well-being and daily life skills. So students develop healthy habits, emotional regulation, and practice practical skills through relevant real-world investigations, right? So they're learning not only about themselves, they're learning about their world, and they're learning about each other and how to connect and communicate successfully in that manner. Number 4, multiliteracy. So here, phenomena-based learning requires students to interpret and create meaning across multiple modes, right? So we're going to be asking the students to look at the challenge or the issue from several different directions, using images, using data, using videos, using reports, using studies, using case studies, that kind of thing. Number 5, ICT or technology. So digital tools to support research, collaboration, creation, presentation. Working life competence. So number 6, collaborative projects mirror workplace dynamics. This is a big one because the students will be able to feel like they are practicing for their future. So it will give them a sense of responsibility or a sense of ownership, right? That what they're doing can affect their future. And then in number 7, participation and sustainable future. So students examine local and global phenomena, developing agency to contribute to sustainable communities and processes that are going on around them. So how do we implement this phenomenon-based learning, this approach? First step is to start with the phenomenon. So you have to pick one. And I shared with you the examples earlier, but there are so many more. You can use one that's just local in your community or in your city, or you can use one that's global or more general, like the ones I suggested earlier. So 1, pick a real phenomenon. It should be observable. It should be tangible, something students can experience directly through their senses. It needs to be familiar. So if you're teaching grade 1, the phenomenon is going to be slightly different than a grade 6 or a grade 12, right? So we need to make it a familiar and connected to their lives or their home or their school. Then it needs to be relevant. So the phenomenon should matter to the students, connect to issues that they care about. It needs to be multidisciplinary. So we're selecting a phenomenon that naturally integrates multiple subjects and ways of knowing. And it's connected to the student's life. So it's a bridge from school learning to the student's identity or their culture or their experiences. Just a tip here, we need to involve students in phenomenon selection when possible. When learners help choose what to investigate, engagement and ownership increase dramatically. We want to make it relevant to them, and the best way to do that is to give them an opportunity to choose. Step 2 is to design the inquiry question. So some characteristics, let's start with the characteristics of strong inquiry. They need to be open-ended, having multiple possible answers. They need to be genuinely interesting to the students. They require investigation to answers, can't just come off the top of their head. It needs to connect to the curriculum, competencies or expectations. And it needs to invite multidisciplinary thinking. So they can't just look at it from a mathematical perspective. They need to use a scientific or an English or an art or a drama perspective, right? How they can present. So well-crafted inquiry questions are the engine of phenomenon-based learning. Unlike closed questions, those would be yes or no questions or with single answers. Inquiry questions open doors to exploration, debate, and deep thinking. They invite multiple perspectives and require investigation to answer. So some starters might be why does, or what causes, how might we, blah, 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 or what would happen if. These are great starter questions to either give the students opportunities to create their own inquiry questions, or as the teacher, you can develop these. But ideally, you want to present these question starters to the students and the phenomenon that they chose and ask them to develop those questions. All right, step 3 is to plan the student investigation. So here, the students are investigating where learning comes alive. This is where it really, the progress really happens. So rather than absorbing information passively, students become active builders of their own educational journey through hands-on activities, mind exploration, planning diverse investigation types that honor different learning styles and intelligences, right? Everybody has their own preference, and so they can do that here. So number 1, we're going to explore navigating environments with curiosity, noticing patterns, raising questions about what they're observing. Then they're going to observe, watching the phenomenon carefully over time, recording details and changes. They can interview experts in the field or community members. They create artifacts, artwork, designs that represent their understanding or their findings. Can be spreadsheets. They compare, so they're going to analyze similarities and differences across examples to identify patterns and principles. They can build models, constructing physical or conceptual representations. This can be technology work, or it can be hands-on in the physical world with supplies and materials. They're solving problems, so they're applying the learning, all of this research, all this observation, all this data they're collecting. They're now going to apply their learning to address a real challenge related to the phenomenon and how they could potentially solve it. And then the last step is to test some of their solutions and see how effective they are, and start that process again and see if when they implemented their solution, how the data changed, what they observed differently. Step 4, the teacher is the designer, not the director. So the teacher's role transforms from information giver or the know-it-all in the room to the learning designer. So the teacher will come with some options, a skeleton or an outline, and the students will take the responsibility of filling in the gaps. Teachers will step back from center stage to create space for student agency. This doesn't mean less work, it's just different. The teacher will spend more time observing and facilitating as opposed to lecturing or directing. So traditionally, the teacher in the classroom will explain the concept, provide the answers, control the spacing and the pacing and the direction, evaluate the correctness, give an exam, manage the behavior of the students. In a phenomenon-based classroom, it's completely different. The phenomenon-based teacher is the facilitator. So she's asking more questions. They've come up with one. Now they've done some observations, but what other questions can we think of? How can we look at this concept or this challenge or issue differently? Provide materials for enabling investigations, facilitating groups for communication and collaboration, documenting the learning to make thinking visible. So this is where the teacher will do the reporting of what she's seeing, writing down observations, and taking note of the progression of learning that's happening. And then along the way, continue offering moments of reflection for the students. So this is a key mind shift, right? Your expertise shows in the questions you ask, not the answers you give. Students trust students to construct understanding with thoughtful guidance. All right, step 5, make learning visible through reflection. So reflection is one of the biggest educational components that are missing in the classroom today. Because in the research that has been done in Finland, reflection is truly what anchors and provides that visible learning. The student, that's where the students are connecting the dots. That's where the light bulbs go on. So reflection transforms experience into learning. Visible thinking routines provide structured ways for students to examine their thinking, articulate their understanding, and recognize their growth. 3 potential recommendations here: connect, extend, and challenge. So connect what they already know, extend with some new ideas, and then challenge with questions. Number 2, claim, support, and question. So here we're going to claim what conclusion can be made. So making an assumption or a prediction. Then we're going to support with evidence this claim or this prediction. And then we're going to question again, did this solve the problem? If it didn't, what new questions should we ask? The third one, I used to think, now I think. So here we want students to say, what was my initial understanding? Now that I've observed, I've researched, I've collected data, I've presented, I've tested, all of these things, how has my thinking changed? And because what caused this shift? Why now do I have a different thought? So we use these routines consistently throughout the unit. Over time, students internalize these patterns of thinking and apply them automatically, developing metacognitive awareness that serves them across all learning. So phenomenon-based learning begins to touch all classes when they create this routine and their mind begins to follow these patterns. Okay, so a small group activity would be a mini inquiry, right? So here they can experience in a very short amount of time a phenomenon-based concept or approach. You'll look in groups, work in groups of 4 to conduct a rapid inquiry into a simple phenomenon, applying the principles we've explored. This is a great way to introduce this idea of phenomenon-based learning. Once the students are familiar with this approach, you can use the more in-depth process that takes a month or more to do. So again, the teaching strategies change. We're rotating quietly between groups, listening more than speaking, using prompt cards with questions like, what do you notice? Why might that happen? Managing time with a visual timer so students can learn to pace themselves, and giving roles to the students or asking the students to take on leadership roles. So let's just take this small mini inquiry and apply it to a phenomenon. How does water move in our school? So this will be roughly a 20-minute experience. The students will break up into groups and then do an observation for about 5 minutes. They can choose one area of the school compound and carefully observe how water moves. Maybe if it's rained, maybe coming from the faucet, looking at the drains, etc. Then they will sit and draw or write what they observed, creating a simple diagram showing the water's path and the movement patterns that they observed. And then they will share their findings. So 10 minutes of sharing, presenting their findings to another group, comparing observations and identifying patterns. After the activity, the students can reflect on both the content, the water movement, and the process, how inquiry felt. What worked, what was challenging, how did the roles support collaboration? You can also use in the bigger phenomenon-based projects, you can use choice boards. These give students autonomy and agency in the learning process. So here it amplifies engagement and allows learners to showcase understanding through their strengths. A choice board offers multiple pathways for students to synthesize and communicate their learning through this phenomenon. So these are just some examples: creating a poster, building a model, recording a short video, making a slideshow, performing a skit, drawing a storyboard, writing a comic, making a mini podcast, or designing an infographic. So all formats should address the core inquiry question and demonstrate understanding of key concepts. Students may work individually or in small groups, depending on the chosen format. A phenomenon-based lesson plan for session 1 would look like this. This is just an example of what a structured phenomenon-based session might look like. So we'll start with rain and water. We're going to make it a grade 5 level. And the inquiry is, where does rainwater go after it hits the ground? So we have a short warm-up, maybe watching a rainfall video clip, asking questions to share one word describing what they notice about how water moves. Then we move into the investigation activity, roughly 30 minutes, where they're observing, going outside, they're documenting, making the sketches, and they're comparing with their groups in reflection. Number 4, they have their routine. So you can choose any visible learning or thinking routine you want. I chose connect, extend, and challenge. So what connects to what you already know, what extended your thinking, and what challenges or questions remain. And then we have the assessment evidence. So the formative observation sketches and the process where the group discussions, notes, capturing student questions and insight. This is just an example assessment rubric that you can share with the students at the beginning so that they understand their goals and they're clear about the criteria that they need to include in their project. And then we also have here our self-reflection for the students. We can use self-reflection after the investigation sessions, mid-unit check-ins, end of unit synthesis, and before and after presentations. And here you can see some of the reflection prompts that I've included. You can use them in journals, you can use them in digital portfolios, or you can just simply use them as exit tickets. And the last thing I have for you is the teacher self-reflection. So just as the students are learning through reflection, a teacher will also learn through reflection. So giving the teacher opportunity to reflect on her part in the phenomenon approach. After each phenomenon-based learning session, take a few minutes to consider what worked, what challenged the students, and how you might refine your approach. So that is phenomenon-based learning in a nutshell. Thank you for exploring it with me. Together, we can create classrooms where curiosity thrives, agency flourishes, and learning connects deeply to the world students inhabit.